Hello everyone, thank you for joining us here. We're going to do a quick demonstration in PropCad 2022 on designing a 5-blade cambered propeller. To start out here, we're going to begin our new project. We'll put in a demo, a description here, so 5-blade cambered prop. And we'll go down here and set up it as a right-hand 5-blade propeller. We'll input our diameter of 38 inches. The reference pitch is going to be 40 inches. And we'll actually input 10 degrees of rate into our design. To get started here, we'll first input a hub based on our propeller diameter. There's some estimates in the software here, and we just accept the default estimate. And then we're going to go into our blade designer, which we call the builder. So this gives us all the parametric options for building our propeller. And a lot of times, a good start would be one of these series-based propellers. So we can select like a typical B-series design. Everything in the table will be filled in for us automatically, and we can hit OK. So here's our first starting point of our design. One of the first things we'll want to do is come in here and actually intersect our blade and our hub. So we'll right-click this table here, and we're going to add a new slice inside the hub here. So we'll just click the Add button, and we'll say, we'll put it at, say, 12%. Hit OK. And what it's actually going to do here is add that in, spline in all those values, and we rebuild our design. OK, and now our blade is connected into our hub. Now the next thing we want to do is look at the actual foil shapes here. So one thing we can do is we can generate the drawing, and we can use the expanded view here, and we'll turn off some of these intermediate sections so that we can see what exactly is going on with our shapes. So we've got these typical airfoil shapes here, but what we want is actually like a flat face to start with, and then we'll add the camber into the foil shape. So what we're going to do is, instead of using these B-series based sections, we're going to go and swap these out for gone sections. Now the gone is a segmental section, which means it's got a flat face, and the back of the blade is made by a circular arc, which is perfect starting point for making a camber propeller design. We come in here, we'll update our drawing, great, and now we can see we've got a nice flat face to begin our cambered propeller design. So now let's go to a typical section like the 70, and let's look at the offsets here. We can just click into the table, and we'll see the offsets. And we can actually see our local pitch numbers here. Let me just make this a little larger. So we've got 40 inches of pitch straight across the face here. And what we want to do is add some curvature into the face to get a progression. So we might be targeting, say, like 38 to 42 here to get like a 10%, 4-inch progression on the 40-inch nominal pitch here. What we're going to do is we're going to open back up our builder, and we're going to go to the added camber section. We're going to turn this definition on. And so essentially we're going to take what we have, and we're going to begin adding camber into the blade. The first section here is what the camber looks like in the view of the section here. So from leading edge to trailing edge. And what we want to do is have a C shape here. So we'll basically have kind of a curve added, superimposed in here. And the peak of that C-shaped curve will be right at the 50% mark. We can move it afterward or forward. For now, we'll just leave it there. And now we have our radial parameters. How does the camber vary from the root of the blade up to the tip? And for now, we'll just set this up as a constant camber. So what we're going to do is we're going to add the same amount of curvature into every foil from the root of the blade up to the tip. Now, camber typically varies from, say, 0.5% up to 3%. So when we do an F/C value, 0.5% would be like 0.05, up to a max of, say, 3%. So let's start in the middle here with like 1.5%, and let's just see what that looks like. So we can actually see some progression here. when we regenerate our design, now we can see basically the original shape in gray there, and now our new shape with the camber in there. And I'm just going to clear this up a little bit. So here's just our modified shape. And we can see here I've overshot our camber, so let's reduce this down. We were trying to hit 38 to 42. So it looks like we've got exactly twice as much as we want. So we'll reduce this down to 0.75%. Just a little bit. Less than 1%. All right, 37 to 42. Maybe we just back this off another hair. We should be sitting right about where we want to be. All right, so we've got 38.1 and 41.8. And maybe just one last time here, I'll bump this up to 65. See if we can hit it right on the nose. Boom. All right, 38 to 42. That's what we want. So now we should have this same curve, whether I go down to the 50, whether I go down to the 30, up to the 90. You can see it's basically added in that progression into all of our blades. And let's now look at the drawing so we can just see. And that is looking quite nice. So we've got a little bit of curvature in there, and that's really what we want. So now we can look at our propeller here. We can see the blade's no longer completely flat. We've got a nice curved profile in there so that we can better handle cavitation, increase our thrust, perhaps boost our efficiency slightly, all the things that Camber's used for as a design objective. And at this point, we're really ready to just export the blade and start going into regular CAD. Well, thank you for joining us on this quick topic demonstration on adding Camber into a propeller blade design, or basically designing a blade with Camber. We look forward to seeing you on more short topic videos using HydroComp PropCad.